Hi guys, I hope that you're all doing well. Today's lesson is about negative exponents. So the law states that a positive exponent in the denominator is the same as a negative exponent in the numerator. What this basically means is that to make a negative exponent positive, you move the base to the other side of the fraction line. For example, if it's in the numerator, or if you have a numerator with a negative exponent, let's say x to the power negative n, you have to move it to the denominator to make it positive. We have negative x to the power negative n. It's basically x to the power negative 10n over 1, right? So you have to take this negative n to the denominator. We'll have x. It changes from negative n to positive n. Now, if it's in the denominator with a negative exponent, you move it to the numerator to make it positive. For example, if you have, let's say, 1 over x to the power negative n. If you want to make this exponent positive, you take it to the numerator. So you'll have x. It changes from negative n to positive n. Now let's try to simplify x to the power negative 5. How do we solve this? We take this x to the denominator. And we'll be left with the 1 over x to the power 5. Now how do we solve 1 over y to the power negative 4? We have to take this y to the numerator so that our exponent can turn from negative 4 to positive 4. We'll have y to the power 4 as our answer. Now let's try something different. If we have, let's say, 3x to the power negative 2, how do we solve this? You have to note that this negative 2 belongs to the x, to the variable, not 3. 3 has its own exponent, it's positive. You know that when you have 3 or just anything, it's basically 3 to the power 1. There's an invisible 1. So 3 has an invisible exponent, it's 1. So it stays exactly where it is in the numerator. We only move x to the denominator. This is basically 3x to the power negative 2 over 1. So we take this x there. And we keep this 3, it'll be 3 over, we take the x to the denominator. It'll be x, instead of negative 2, it'll be positive 2. Now let's try something else. Let's solve or simplify a to the power negative 3 over b to the power negative 6. Can you guys see that both terms, a and b, have negative exponents? So to make them positive, we basically have to swap places. A goes to the denominator and b goes to the numerator, and they change signs. So we'll have, let's take this b to the numerator. It'll be b to the power 6 instead of negative 6 over a, because you took a to the denominator, right? A to the power positive 3. Now let's try 2 over 5x to the power negative 7. How do we solve this? 2 and 5 have positive exponents. The exponent is 1, the invisible 1. So they don't move. Only the x to the power negative 3 moves to the numerator, so that we can change from negative 7 to 7. So in the numerator, we still have 2. We write down that 2. We move this x to the numerator. It changes from negative 7 to positive 7. Over, in the denominator, we still have 5. So your answer is 2x to the power 7 over 5. Now let's try a few practice questions. Now let's try x squared y to the power negative 3 y to the power 7 all over x to the power 4 y to the power negative 1 x cubed. How do we solve this? We firstly have to check whether we have any similar bases. We have x in the numerator and y and y. We can solve that. This is basically y to the power negative 3 times y to the power 7. You have two bases that are multiplied, so you add their exponents. This will be y to the power negative 3 plus 7, which is y to the power 4. So you have to write this here. You have x squared. You write the x squared as it is. You have y times y to the power negative 3 plus 7. all over. In our denominator, we have x, y, and x. We have two x's, so it's x to the power 4 times x cubed. You have the same bases that are multiplied, so we add the exponents. This will be x to the power 4 plus 3, which is x to the power 7. So we have to show this here by writing down our x. We have 4 plus 3. We write the y to the power -1 as it is. Now let's calculate. We have x squared as it is times y. Said -3 plus 7 is 4. All over x 4 plus 3, which is 7, times y to the power -1. Okay, now let's try to solve this part. You have x squared times y to the power 4. We don't have any similar bases, so we can't really solve anything there. Then x to the power 7 times y to the power -1. You don't have any common bases. So we can try to look at the fraction as a whole. We can go across. We have x to the power 2 and x to the power 7. Then x to the power 4, y to the power 4 and y to the power -1. Let's start with the x's. This is x to the power 2 divided by x to the power 7. You have the same bases that are divided, so this will be x to the power 2 minus 7. X 2 minus 7 is equal to -5. So we can show this here by writing down our x 2 minus 7 times we have y to the power 4 divided by y to the power -1. You can write this on the side so that it's less confusing. Y to the power 4 divided by y to the power -1. How do we solve this? You have the same bases that are divided, so we subtract the exponents. This will be y to the power 4 minus, put this -1 in a bracket. You have y, 4 minus -1 should give you 5, +5. We have to show this here. We wrote down our base, which is y, 4 minus -1. Now let's solve. X 2 minus 7 is equal to -5 times y to the power 4 minus -1 is +5. So is this our final answer? Let's check. You have x to the power -5 times y to the power 5. X has a negative exponent, y has a positive exponent. X has a negative exponent, y has a positive exponent. So we can take this x to the denominator so that we can have a positive exponent. X to the power -5 times y to the power 5 is basically x to the power -5 times y to the power 5 over 1. So let's take this x to the denominator. We'll be left with the y to the power 5. It's positive, so we leave it as it is. Take this x to the denominator, we'll have x to the power +5. And this is your final answer. That is how we deal with negative exponents. Now let's do another problem. Let's try 2xy to the power -3. Outside our bracket, we have a -2. Then over 2x to the power -2, y cubed, outside our bracket, we have a 3. How do we solve this again? We firstly have to check whether we can simplify in the bracket. In the bracket, we only have 2xy to the power -3 in the numerator. So we can't really do anything. So for the next step, we can distribute the outer exponent to every term inside the bracket. You multiply the exponents. You have to raise. Remember this rule. Okay, this has to go there, this has to go there, this has to go there. Now let's solve. We have a 2 there. Okay, so this will be 2. You guys know that this is basically 2 to the power 1. So it'll be 2 to the power 1 times -2, right? 2 to the power 1 times -2. Let's move to x times x. This is x to the power 1. You know this because you watched the grade 8 videos. This is 1 times 2 times -2. We're left with the y to the power negative 3 times negative 2. And we're done in the numerator. You distributed the negative 2 to every term inside the bracket. Now let's move to the denominator. We'll calculate in the next step. In the denominator, we have 2x to the power negative 2y cubed. Outside a bracket, we have a 3. So we have to distribute this 3 into every single term in the bracket. So we have 2, which is basically 2 to the power 1 times 3 times x to the power negative 2 times 3 times y to the power 3 times 3. That is how we distribute. You guys know this law as you've done it multiple times. Now let's calculate. In our numerator, we have 2 as our base, then 1 times negative 2, which is negative 2, times x. We can just write this as x. You don't have to include the multiplication sign. 1 times negative 2, which is negative 2, then y. Negative 3 times negative 2 is positive 6. All over. In our denominator, we have 1 times negative 3. We write down our base 2. 3 times x. Negative 2 times 3 is negative 6. Times y. 3 times 3 is 9. So this is what we have. 2 to the power negative 2, x to the power negative 2, y to the power 6, all over 2 to the power 3, or 2 cubed, x to the power negative 6, and y to the power 9. Now, what should we do next? Let's check. Do we have any common bases so that we can simplify the numerator and the denominator? We have 2xy. No. In the denominator, we have 2xy. So we can subtract the bottom exponents from the top exponents. We check, or we look at our bases. We have 2 and 2. Let's write this on the side. This is basically 2 to the power negative 2 divided by 2 cubed. You have 2 bases that are divided, so we subtract their exponents. This will be 2 to the power negative 2 minus 3. We show this here, 2, negative 2 minus 3. We're left with x. We have negative 2 and negative 6. If you need this on the side, it's basically x to the power negative 2 divided by x to the power negative 6. We have 2 bases that are divided, so we subtract their exponents. We'll have x, negative 2 minus, in a bracket, negative 6. So we show this here. We have x, negative 2 minus negative 6. Don't forget to put the negative 6 in a bracket. We're left with 9. We're left with the y, which is basically y to the power 6 divided by y to the power 9. We have the same base, and they're divided, so we subtract their exponents. We write down our base as it is y, then 6 minus 9. So here we'll have y to the power 6 minus 9. Now let's solve. You have 2 to the power negative 2 minus 3, which is 2, negative 2 minus 3 is negative 5. Times x, we have negative 2 minus negative 6. Negative 2 minus negative 6 is 4. Then y, we have 6 minus 9, which is negative 3. So do we have a final answer? Let's check. We have 2 to the power negative 5. It's a negative exponent, so it has to go to the denominator. Then x to the power 4, we leave it there as it's a positive exponent. And then y to the power negative 3, it also has to go to the denominator so that we can change the sign of the exponent. Okay, what do we have now? In the numerator, we only have this part as it's positive, so we leave it as it is. Then 2 to the power 5. It was negative, it should be positive. Then y to the power negative 3 goes to the denominator, and we'll have y to the power 3, or y cubed. You can try to take this a step further by calculating y to the power 5 we'll still have x to the power 4 over 2 to the power 5 is 32, y to the power 3. This is our final answer. Now let's try the last problem. Let's try a over b to the power negative n. How do we solve this? You can take the b to the numerator and a to the denominator. So we have b over a, and this sign changes from negative n to positive n. But if you want to be technical and see how we got this, we'll have a to the power b negative n. Remember, we have a negative n here, so we distribute this to the a and b. We'll have a in the numerator, we have a, which is basically a to the power 1 times negative n, over b, which is basically b to the power 1 times negative n. We'll have a, 1 times negative n is negative n over b to the power 1 multiplied by negative n, which is also negative n. So when you change the sign of exponent, you have to take the variable to the other side. So the b goes to the numerator and the a goes to the denominator. So this will be b to the power positive n over a to the power positive n. When you factor this n out, you'll have in a bracket b over a raised to the power n. If you want to make sure, you can just factor this in or distribute this. You have b, which is basically b to the power 1, right, multiplied by n, over a to the power 1 times n, which is b to the power n over a to the power n. Can you see that this is similar to that? You can just flip this or take it step by step. It honestly doesn't matter as long as you have the right final answer. Now let's try another one. Now let's try x over y raised to the power negative 2 times y over x to the power 3. So we can try to change this negative exponent and make it positive. Let's distribute this if you want to see all the steps. We have x, which is basically x to the power 1 times negative 2, in a bracket, over y to the power 1 times negative 2. In the next bracket, we also have y to the power 1 times 3 over x to the power 1 times 3. So we should have x to the power 1 times negative 2 is negative 2 over y to the power 1 times negative 2, which is negative 2, times y, we have 1 times 3, which is 3 over x to the power 1 times 3, which is also 3. Let's try to have positive exponents only because they're easier to work with. We take this y there and that x there. In our numerator, we now have y to the power 2 or y squared over x squared times y to the power 3 or y cubed over x cubed. So now we have the same bases that are multiplied. Can you guys see that this is basically y to the power 2 times y to the power 3, then x to the power 2 and x to the power 3. So you can write this on the side as y squared times y to the power 3. This is how we work with fractions. Over, this is so y squared times y cubed. You have the same base and they're multiplied. So we add the exponents, 2 plus 3, which is y to the power 5. So you show this here. This is y 2 plus 3 as they are multiplied. 2 plus 3 over, you have x squared times x cubed. X squared times x cubed You have the same base and they're multiplied. So we add their exponents. This is x to the power 2 plus 3, which is x to the power 5. So you have x2 plus 3. Now let's calculate. We should have y to the power 2 plus 3, which is 5, over x to the power 2 plus 3, which is also 5. So our answer is y to the power 5 over x to the power 5. However, we can factor out this 5. We'll have y over x in our bracket, and we should put our 5 there. If you distribute this, you should get y to the power 5 over x to the power 5. And that is how we deal with negative exponents. Thank you guys for watching. I hope that this lesson was helpful. If you have a few questions, you can always comment. Thank you for watching. Please like and subscribe. I'll see you guys in the next video.